Okay, so we are trying to evaluate this limit, and my first step would be to try just stick -1 in place of x and see what happens. And we find out that if we do that, we end up with a 0 on the top, we end up with a 0 on the bottom, and it's just not going to work out. So we need to do something, and our second step then would just be to try some algebra, see if we can rewrite this in a way that doesn't give us that 0 over 0. One thing we can do algebraically here is we can try to do something with this square root. And the general way we get rid of square roots when we have a fraction is by multiplying by the conjugate. So if I got, an expression here, a minus b or a plus b, the conjugate would just be changing that middle sign, that sign that's between those two terms. So I'm going to do that. I'm going to multiply here by x plus 2, the square root of x plus 2 plus 1. I'm going to do that to the top, and I'm going to do that to the bottom. So that gives me the square root of x plus 2 minus 1. That's the same thing I have over here. But I'm multiplying that by the conjugate, square root of x plus 2 plus 1. And in the denominator, I have x plus 1. And I'm multiplying that by this term over here. Remember, if I'm trying to keep everything equal here, so if I multiply something by the top, I got to do it in the bottom as well. So I got the square root of x plus 2 plus 1 being multiplied down there. And I can see, well, these two things could cancel out, and I would just go back to the original problem I had. But that would kind of undo the thing I'm trying to do here. Let's see what happens here. If I multiply all this stuff out, now these are just two binomials, so I'm just going to multiply this the normal way. Multiply the first terms, multiply the outer terms, multiply the inner terms, and multiply the last terms. Now the first terms, the square root of x plus 2 times the square root of x plus 2 just gives me x plus 2. The outer term gives me the square root of x plus 2 times 1, and the inner term gives me negative square root of x plus 2. And so those two things are just going to cancel each other out, and I'm left with the last terms, which would be -1 times 1, which would be -1. And so that's my numerator. In the denominator, I have an x plus 1, and that's being multiplied by the square root of x plus 2 plus 1. And I see that the numerator here just becomes x plus 1, right? Just combine the 2 and the -1. And the denominator, I've got an x plus 1, and I've got the square root of x plus 2 plus 1. And this x plus 1 and this x plus 1 can cancel out, leaving me with the limit as x approaches -1. In the numerator, I've just got 1, right? Because if I divide the top and bottom here by x plus 1, then that cancels that out, leaving me with 1. In the denominator, I have the square root of x plus 2 plus 1. And I've rewritten my expression. Now, I know that's a little bit messy, but the whole idea here is that limits are algebraic. You can do algebra, and it's not going to change the value of the limit. And sometimes we just have to play around with things here just to see if we can rewrite that function in such a way that it gets rid of the thing that's causing the problem. And in this case, if I go ahead and plug a -1 into my x at this point, I don't have any more problems. I get a 1 on top. I get the square root of -1 plus 2 plus 1 in the denominator. Well, this is just 1, and the square root of the 1 would just be 1. So I just have 1 plus 1 in the denominator here, and that gives me 1/2.